Okay, hello everybody. Welcome to the next edition of Captivating Conversations. This podcast has covered a range of things, but today is something pretty darn special because we're talking about AI. Now, most of you know who I am, and I'm a technical, useless person when it comes to technology. The closest I've got to AI is probably something like absolutely incredible rather than artificial intelligence. So it's with great pleasure I introduce you to Vangelis Calgary. Thank you, Vangelis, for your time today, because I want people to actually get to truly understand what AI is all about. And you've got a unique and a comprehensive skill set because you've had hands-on experience, and I'm quoting here from what I've got from you, with all components required to support AI technologies, including their development, their implementation, and their integration. And that to me covers a whole lot of territory. So, Vangelis, thank you for your time today.
Well, thank you so much for having me, Peter.
So, do you mind if I ask you some questions? Are you ready to go?
I'm ready to go. Go ahead.
Okay, and now bear with me. If they sound simple, remember that I probably represent a vast majority of the population. So, the first question is this: what in the heck is AI? And whilst you're doing that, do you mind also answering what is an AI agent?
What is an AI
Agent.
Agent. Well, it's a good question because AI is not a program and it's not an application. In fact, I'll even take you way back. Many of you may have remembered these calculators. In fact, there was a TI calculator, years ago, Texas Instruments. It's any time that you put information into a computer is not flesh and blood. And that was their whole idea. It's intelligence put into something that's artificial. But it could also be thought that it's artificial intelligence. And I'll get to that also later. But you're putting a program into a calculator. And it's just this little machine, and you put, 3 + 3 is 6, and so forth. But the reason that it's also artificial is because if you put 3 + 3 is 7, that computer would not be able to say that's incorrect. So it's any time you put any type of information, intelligence, into a computer, that's what they're calling artificial intelligence. Now, as time went on, and the first computers came out, 1973, Xerox comes out with their personal computer. And then 76, you have Apple, 77, the Commodore, 1981, you have IBM. And what they did was the idea was you took a mainframe, which was the computer part of it, and you put that into a little computer in a box. And then you have this huge disk arrays, and you put that into a little disk in a box. And then you have this little card that connects you to the network, and that was this network, big, huge device. And then you have this monitor. And so you could actually think of it as they put the mainframe, the big hardware disk, the network, the card, all of it into a little box now. And so you actually have what they used to have, this huge 6x6x8 mainframes. Now they just kind of made it smaller. But in 1959, the mainframes had about 128K of memory. Well, my phone today has 128 gig. So you're seeing now that it's just the computer is a computer is a computer. All right. So AI then is basically all of those components, all those technologies, the computer, the storage, some type of security to secure it. And then you have the network part of it. And then you have the programming part, which is the model. You have the input into the model. You have the programming of the model itself, like maybe a Python program. And then you have an output. Someone analyzes it. So that's the hardware software side. Then you have the people side. You have the customer that has some requirements. You have the sales and the engineer person. Then you have the project manager, which says, okay, what are the requirements of the customer? They're going to put it to a project. And then that information goes to an IT person that goes into the data center, the storage people, the network people, the security people. And then you have all the scientists, the ones that input all the stuff and then put the model and put the analyst. And then you have the executive. So that's the people part. All of that is AI. That makes sense.
Okay.
So all of that's AI.
So does that mean, in simple terms, and correct me if I'm wrong, that it's still simulating human intelligence? Is that right?
Yes, and I'm glad you said that way, because you see, I was back in 2003 is when I started programming computers to interact with humans. Right. So if you when I was teaching AI to a bunch of scientists, I'll give you one example. This one organization was trying to teach this computer to detect a certain object. And let's just say, I did a lot of military stuff. So let's say they want to detect a tank. Okay. And so they were saying, well, it worked in the test model, but it didn't work out in the field. And I said, okay, do any of you have children? I said, well, yeah. Okay. So when you have a child and that child is born, when you pull them right out of the womb, right? You'll notice that the child's eyes are doing this. They can't focus. Why? Because they don't know what they're looking at. It's like all they see are just pixels. Right? And so I showed these scientists a couple of slides and I said, see all these pixels? You can't make out what it is. Then I show them the next slide. And the next slide, finally, they see a house, a tree, a chair, a dog, a fountain. But in the beginning, the child has no reference. Neither does the computer. So here's what I see a lot of parents do. Oh, look at the dog. And the child's going, you, the adult, see a tree,
Yeah.
a bench, a house, a fence, a bush, a fountain, and a dog. The child sees pixels.
Oh,
Now,
yeah.
when I explained that, the scientists went, that's why we're not being able to teach the machine how to detect a tank. Exactly. Because you are showing the machine 15 items.
Yeah. Yeah.
The way you teach now, and then I joked with them. I said, please don't tell me you have children. Because if you're teaching your children the same way you're teaching a machine, no wonder the child's going, doggy, no, that's a tree. Doggy, no, that's a bush. Dog, this is the deal. So child, machine, neither has a vocabulary when they start, neither has a reference of anything at all. In fact, if you told the child 3 + 3 is 7 and the machine 3 + 3 is 7, they'd both go, okay. Because they have no reference, nothing.
Yeah. Yeah.
It's all artificial. So whatever you teach that machine is what it's going to tell back to you. Whatever you teach the child, it's going to say right back to you again.
Is that
So
like garbage
that's
in, garbage out? Is that like garbage in, garbage out?
yeah, but you know, when you say it like that, it sounds kind of as a bad connotation. But it's information in, information out.
Okay. Okay.
Is really
That
basically all it
point.
is.
Well, let me reframe it by saying that if it is simulating human intelligence, okay, then these machines can learn, right? They can reason, they can solve problems probably quicker than you and I can ever do, and they can adapt. Would that be true?
Based on your parameters. Think of a child. If you gave the child information on how to do car repair, that's where it would be able to reason and adapt and think on its feet. If you told it how to do financial balance sheets, it would not be able to take care of a car because it hadn't been shown that yet. It might figure it out, but it would take a while because they have no reference.
Okay. Okay. So that leads me to my next question, because we don't want to have a machine with its eyes rolling around like a baby who's been confused, right? So how do you teach a computer?
Well, for example, just to show you how a child learns, all right? So we have
Mhm.
this video of this 3-year-old child, and we're showing the 3-year-old child, there's Julie. And the child goes, no, Julie wears a red dress. Well, Julie has a blue dress on today. That's not Julie. She wears a red dress. Well, today Julie has a blue dress on. Okay. And the next time, there's Julie. No, Julie has a red or a blue dress. We have a video of this child, just so that you can see how literal
Yeah.
the child is. No difference in the machine. So what we do is we show the machine. I said, look, here's how you teach the machine to detect a tank. Just a tank, nothing else on the picture. And you show the tank from here, 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 top, bottom, side, up, 100,000 different angles.
Mhm.
So that way, in case the machine sees it from here, oh, I've seen that before. From here, I've seen that before. So show the child a dog, all right? Here's a dog. What's this? I don't know. That's a dog too. But I know it looks different than that dog. But this is a dog too. So you show the child 50,000 pictures of dogs from all different angles too. And a dog that's wet, and a dog that's dirty, and a dog that's sitting, and a dog that's laying. You see what I mean? It's
Yep.
so literal because the child, again, no, Julie wears a red dress, not a blue. This is how you have to realize how machines and how children think. Once you understand that, your ability to train will be so much more effective and efficient because you're going to realize you have to start from zero. Zero.
Hmm. With one important distinction, I guess, and that is, unlike us, a computer never forgets, right? It just keeps learning.
Yeah, it keeps learning based on what you have input. See, again, if I gave it 3 plus 3 plus equals 7, it would keep learning and using that. It's like when I was, a lot of times adults don't realize they slur stuff. And I remember hearing in elementary school, it's just a doggy dog world. Now, what I heard at 6 years old, DOGGY, doggy dog world. I didn't see it spelled, and they didn't pronounce it like it's a dog eat dog world. That's how I would teach a child. It's a dog eat dog world. 3 words.
Mm.
But those teachers don't know how to teach like that. They didn't
Mm.
know, at least mine didn't. And those of you that are teachers, I deal with people that have 3 PhDs, all right? Because you're not realizing how to get into a zero, I know nothing situation. All right. So you have to it's just like my 4th grade teacher, she said, which way does the earth rotate? Clockwise or counterclockwise? So I raised my hand. Yes. Are you looking down or up? And my teacher, what? Please don't tell me you didn't think about that. This is what I'm talking about.
Mm.
Here I am in 4th grade going, you're my teacher?
Mm.
Okay, so now I'm much older and I'm teaching scientists now, and it's no different. Same thing. I'm going, okay, you're giving it too many parameters. Let's do it very, very slowly. It's just like when you teach a child. I have one slide that I show people. It's like when you teach a child a number 2, all right? So you draw a 2, okay? And then you have to draw a 2 with a little swirly thing at the bottom because they'll say, well, what's that? Well, that's also a 2. Yeah, but look, I know it looks different than the other one. So I draw like about 50 different ways to draw a 2 so that the next time they or the machine sees that 2, they'll go, I've seen that. You see what I mean? It's no different than if you have seen something, but you haven't seen this, it's unknown to you. And whenever anything is unknown, you might be able to go, kind of looks like a 2,
Mm.
right? So then what you do is you give the machine, all right, what do you think that is? Looks like a 2. Yes. Oh, good. Now the machine learned. Next one looks like a 3. No, it's a 2 also. And then tries again. And because you do this so quickly, hundreds and hundreds and hundreds and hundreds and thousands of times, eventually the machine learns. But if you gave it a million different 2s, it would go 2, 2, 2, 2, just like a child. Oh, there's Julie. Today she has a green dress, a blue dress today, a red dress today, a black. How do I know? Because my mom and dad told me Julie can wear 50 different colors, and maybe it's a shirt and a shorts today, and maybe it's green tennis shoes instead of white. You see what I mean? So now the child is realizing there's variances here. Yes. So what are the common things? Her face, her eyes, her nose, her mouth. Oh. You see what I mean? So this is how you train a child, and this is how you train a computer. You just start giving them all the variations slowly, and you ask them, what is this? What is this? And then based on their answer, they go back and learn. That's called iterations. They go back and learn, okay, I got that one. Ooh, didn't get that one. And so now they're learning. And that's called deep learning when they figure it out.
Now, let me clarify in my head something. Are you saying that in terms of, forget the child, I hear the analogy very clearly, right? But in terms of artificial intelligence, that the information, that the actual ability to do the job of artificial intelligence is impacted by the amount of information we put into it? Or do
And
they
the
have,
type of yeah, okay,
or does it
for example,
teach itself?
yeah, it's whatever viewpoint, perspective, bias the inputter has is what the machine spits out. Yeah.
Will the machine ever question that in terms of
If you put that in there, no, it doesn't know. See, it's just like before the age of 8, a child doesn't question anything. They don't have the physiological development of the brain yet. The machine doesn't question anything unless you give it a questioning parameter. If you hear this, question. If you hear this, question. If you don't put that in, it doesn't know to question.
So it's like our subconscious. Our subconscious doesn't know whether you're telling you to lie or not, right?
Exactly. Your subconscious is unbiased, non-judgmental, and has no time.
Right. Well, now that leads me to the next question. Wow. Does AI have a consciousness?
Whatever is in the consciousness of that person configuring it is all it has. Now, can it connect to the collective consciousness of the fourth dimension? No.
What does that mean?
Can't do that. But what it does that's close to it is every day it gathers about 0.5 gigabytes of information from every person on the planet. Now, how does it do that? A variety of ways. Every time you click on a web page, they took away your ability to take your battery out of your phone. Why? Because when you turn your phone off and you put a UV meter and you shake your phone, the meter registers frequencies, energy, because this never turns off. Okay. That means that it's always listening. And anytime you're on your machines or whatever, depending upon your firewalls and stuff, it's always listening, right? How many, in some of my classes, people would say, well, I just like my privacy. I go, really? Do you have Alexa or Siri? Yes. So you really think that the only time they're both listening is when you say their name? So when you say, hey, honey, what's that password to the bank statement? The banking account number. Okay. Alexa, play this music, please. Sure, I didn't hear that bank statement password. Oh, thank you for not listening to that. But you see what I mean? You've got to really understand how, see, I worked on a lot of military bases, a lot of stuff. My students I had one class, the guy said, I work for the executive office. I said, well, What do you mean? I do the networking for the executive office, the president. Oh, really? So, I mean, I'm telling you, I've been in stuff that you wouldn't even believe. So I have a really good understanding of there's a lot of stuff that's listening to.
Mm,
We have
mm,
sensors. That's why they created something called IP version 6. The internet was originally on IP version 4 back in 1972/73. Well, they knew in the 90s they were going to run out of IP addresses. So they came up with IP version 6. Now, I have this calculation that I do in the class, but it ends up being that every brain cell of every person. So let's say that every person has about 100 billion brain cells. Okay. Your count may vary, but it's around that. Okay. Every brain cell, not every person, every brain cell of every person on the planet gets about 4.2 quadrillion addresses. Every brain cell of every person gets not one, 4.2 quadrillion addresses. You can address every pen, every cup, every mouse on the planet and have stuff left over. Now, why they do that? Because they want to be able to extract information, sensors.
mm.
All the I was doing some troubleshooting at an electric plant, and I said, so how do you know that this electricity? Oh, we have sensors on every single wire. You mean every single electrical wire? Yes, every single electrical wire. Well, that's millions. Got it. Forgot that every brain cell can have 4.2 quadrillion addresses. You see what I'm saying? So all these sensors all over the world, every electrical wire, every tire, every computer, every building, every whatever it is. In 2012, the FDA approved that the pharmaceutical companies could put a chip in every tablet. Why? So that the doctor would know when the patient would be consuming the prescription. Every tablet, a chip, okay, sends a message to the doctor. Patient took the tablet. Great. Okay. So these are all sensors. This is all information that's gathered into all these computers. So whenever you do a query, it's querying from that database of that. I mean, some of those numbers have like 40 zeros after them. That's how many, right?
Mm.
So these are all these sensors out there, and they're gathering information.
So, Vangelis, correct me if I'm wrong here, but it's possible right now to replace, you talked about brain cells, right? To replace just one brain cell with a chip. We could do that right now, okay? And that chip
Yeah.
could mimic identically what that brain cell was doing, right?
Yeah. Well, okay, in 1958, okay, just so that you know, this is nothing new. In 1958, they put a pacemaker inside a person,
Mm.
and there was a person remotely configuring and monitoring that computer inside that person. 1958. 1958.
Yeah.
So we've been monitoring people, computers inside people's bodies since 1958. So it's nothing new. If you go to the NIH, the National Institute of Health, just do a query. Computer chips inside people's bodies. It's public. There's no conspiracy or, secret. It's all there. I have like 100 documents. I actually have a presentation where I show people all the different things that they put into your body. And they communicate with you through a phone. All right. So all the chips and stuff, the computer, the heart pacemaker, all this stuff. And remember, 2012, you can put chips in tablets. Where do the tablets go? Right? So they have all these things inside your bodies that they can communicate with.
Yeah.
Everything.
But we were
Injections,
talking
dots,
about,
whatever. So all this stuff is there. So those are all sensors,
point
and
taken.
that just gathers information.
Okay. And those sensors, as we said at the beginning of this, we're talking about, does AI have a consciousness, right? And you mentioned a term called fourth dimension, which I'm not sure what you mean by that. So could you help me
Okay,
understand?
all right.
But before you do that,
Um,
does that include self-awareness? Does it include personal experiences? Does it include independent thought?
right. So the only difference between the child and the computer is the child comes with DNA. Now, years ago, they could
Yeah.
only figure out that 10% of the DNA was useful. They used to call the rest of it junk DNA. But once science and spirituality and technology started merging, they realized, wait a second, the other 90% is actually doing something else. And so now these people that talk about wormholes and vortices and chakras and energy cones, now they're realizing there's stuff going on. So there's several books, and these are like in the 50s and 60s. Konstantin Korotkov and B.B. Kavinsky, they wrote a book, Energy Consciousness and Bioradiology Energy, right? And so in these books, they talk about how they wanted to know, where did thought originate? So they put these sensors to find out where the energy source was. And they put these two people in different rooms, and they said, person A, I want you to think a loving thought for person B. And they noticed that the thought energy originated in the heart, went to the brain, because the brain is the receiver transmitter. It transmitted to the other person's heart,
Yep.
that went to their brain, so their brain could signal their body to prepare their body for that thought. Okay, so it's heart to brain, brain to heart, heart to brain. Okay, so now they're realizing, so this really is where everything happens, in the heart. Yes, the heart is so many thousand more times stronger energy than the brain, because the brain is just a receiver transmitter. So all this stuff starts in the heart. Well, if you talk to the people in the Kabbalah or the Upanishads or the Bhagavad Gita, you'll start reading, like in the Kabbalah, the first chapter, it talks about that the wisdom of God. And there's a word in the Bible of Genesis that says, let us make man in our image. It always confused me. I said, I thought there's only one God. Well, when you read in the Kabbalah, that word for God in Genesis is Elohim, which is plural. And when you read in the Kabbalah, it says, this refers to the 32 wisdoms. And I said, 32? There are 32 chakras. Ah, there's a connection. So if I put all that together, in fact, Candace Pert, in her book, Molecules of Emotion, she was in the NIH, and this is like in the 80s and 90s, and she said, she had this shaman come in and say, could I put my chakra diagram over your energy diagram? And she says in the book, it matched exactly where the energy centers are in the body. And she says, oh my gosh. So she started putting spirituality with the energy, with the science, with the technology together way back in the 80s. And so now you're realizing, okay, so if there's 32 chakras and there's 32 wisdoms, and that's what we call the image of God, spirit, universe, that means those energy centers, well, how does it all communicate? How do we all communicate? Well, telepathy, right? So they realized that there are vortices, wormholes, that the DNA then communicates telepathic wise. In fact, they even did this experiment back when Eisenhower was president. They were trying to figure out how to communicate to the submarines because the signaling had difficulty going in the water to the depths of the submarines. So these guys said, why don't we test this out, see if thought to thought works? Well, so that they said, okay, we're going to do an experiment. 12 o'clock at this time, this person on land is going to think about 12 characters, write them down, and the person in the submarine at the same time is going to hear thought-wise, intuitive, telepathic-wise what those were. And it was like 90 to 95% accurate. Whatever the guy wrote here, that guy wrote it on their card. I mean, it's amazing. And then they started using people like in Robert Monroe's Institute in California, where they were doing remote viewing, and they started seeing this stuff. So they started realizing there's a whole world that's going on here. And now, is this new? No. In 1908, Max Planck and Einstein were, corresponding to each other, saying something else is happening because our experiments are not having the same results as yours. They realized that the observing and the thoughts were changing the results of the experiments. So again, that's over 100 years ago. So all this stuff is now merging to where are we communicating? How am I communicating with you, Peter, right? How is it that all of a sudden I think about you and you send me a note? Well, one time, yeah, but maybe what, 10 times, 12 times, all of a sudden, okay, Peter, we're thinking about each other. And that's because when they took that person and put him 2,000 miles away, and this
Mm.
person thought of that person, it was the same time frame as if they were in the other room. It doesn't have any distance. Thought,
Oh.
energy has no distance, no space, no time. Okay. So now these medical doctors and scientists are realizing that DNA is communicating to something else. So what's the fourth dimension? Well, there's a book called Alchemy of the Nine Dimensions. And it talks about how the Earth's crust is dimension number one. From the Earth's center to the crust is two. We live in the third dimension. And the fourth dimension is what you've probably heard of, the collective consciousness.
Yeah.
That's where all you may have heard the words Akashic records, the Book of
Yes.
Life, Shadow Records, all of that lives in the
Okay.
fourth dimension. Okay. So
Mm.
whenever you hear people, oh man, I just, like Tom Petty, I remember someone interviewing him and he says, so how'd you write that song? Oh, something just came across my scanner. Okay.
Mm.
So now I can see, oh, so he was just connected to the fourth dimension, the collective consciousness. Yeah. How can two people on the different sides of the earth have the same creative idea?
Mm.
Because they're connected to the same consciousness. So when you think about we say we're all one, think about an ocean with all these drops. What is the ocean made up of? Drops. And we're all drops. Am I the ocean? Are you the ocean? Well, we are the ocean. Okay. So if you think about all those drops in the ocean, we make the ocean, so we're all one. Now, I have a PowerPoint presentation where I show all these ice figurines. One is a form of a violinist, another one is a fireman, another one is an office person, and all these different figurines are all made from water. So they're all from the same source, but we're all different expressions. So if you think of the fourth dimension as all of us collective, our thoughts, our ideas, that is what the computer cannot connect to. Well, what if I connect it to a person? Yeah, but again, it's just to the restriction of that person. How many people even know what intuition is? I didn't know what it was 15 years ago. I heard it. I didn't know what it was. I took 2 years of clairvoyant, claircognizant, and sentient and audient just so I understand intuition. And now, yeah, I use it. I know what it is, and I consciously use it. But you'd have to be connected to that. And a computer doesn't have DNA. So once again, it's whatever you put in is what you're going to get out. So yeah.
Mm. I mean, this has nothing to do with AI, but I mean, when you talked about telepathy, does that partially explain the reason why you see the statues on Easter Island and you see other statues maybe in Egypt or in Peru have very similar characteristics because there's been a telepathy transfer?
Well, it's because we're all part of the same collective consciousness.
So that's
We're all,
real.
we're all one. I mean, this is why you see such oneness. See, all of us are equal. The only difference is how we see ourselves. That's it. So if you see things in one location, look similar things in other locations, because we're all hearing from the
Okay.
same
Yeah.
source. That makes
Okay.
sense.
Yeah, it does make sense. Okay. I just digressed for a minute. Sorry about that.
No,
All
no,
right.
that is part of it. See, because you're in the process of, does a machine have consciousness? It has whatever the ability of the consciousness of the person who inputs the information, but it
Mm.
can't go any further. It can't tap in to what we can tap into. Even if you put electrodes on a person, what if that person doesn't know how to use intuition, or they have too many traumatic situations and they're living in fear and limiting
Yeah.
beliefs, and that's what the machine will have.
And to be honest with you, I'm on the edge now because I'm trying to assimilate what you as another human being is telling me, right? Not a machine. So yeah, I can hear that. So really, from an artificial intelligence perspective, it's been around in many ways in forms for a long time, but it is true to say that it's accelerating, right? In terms of the impact it's having on mankind. And with that in mind, will it take away people's jobs? Is there a threat to that?
Okay. Back in 1995, I had just been hired as a consultant for Cisco. And because of my IBM background and because I knew IP, they said, okay, we're going to want you to teach all these people about IP, the internet. So I would have people from different companies with different protocols in this class, and they'd be sitting there like this. And I said, guys, ladies and gentlemen,
Yeah.
you can do everything you can to try to stop this train, but it's already left the station. If you can just grab a hold of it, it's just like when people started, I'm not using a credit card, I use cash. It's no different. Horse and buggy, we don't need a car. Okay. Who wants a telephone? Same thing, 17. I mean, it's anytime you introduce something new, there's this resistance. And if you would just realize, well, look, let me look at it differently. Let me look at it to what's really happening here. How can I really take advantage of what this opportunity is giving me? How can I really see it for what it is? So I embraced it and I said, all right, I'm going to learn this. So I was one of so few people that knew the IBM stuff, telephony stuff, and IP. I mean, there were like 5 or 6 of us on the planet back in 1995 because so many people were like, right? And so
Mm.
it's the same thing with this. Artificial intelligence, like I told you, the TI calculator back in the 60s and 70s, it's a machine that's thinking. That's all it is. We put in there. So I have a presentation where I talk about disruptors. All right. So like, for example, Uber. All right. So you had taxis. So in San Francisco, I used to have this statistic where I said, okay, before Uber, here was the millions of dollars of taxi revenue. After Uber, it was like 4 times. Did it take jobs away? Or did it add more jobs and give people more opportunities?
Mm.
Well, if you talk to the people that seem like it was destroying them, they would say no. But if you talk to the people that utilize this new thing, where, oh my gosh, because the first time I used it, I was in Phoenix, Arizona. I called a taxi. 20 minutes later, still not show up. And I'm thinking, I gotta get to the airport. I'll use Uber. First time I used Uber. I oh, hey, there's the car. Oh my gosh, I can see it coming. Now, you're wanting me to stay with a horse and buggy when I can get a car. You see what I mean? It's you've got to start seeing things and figure out, how can I use this to my benefit? So the way that I look at AI, let's say that you're in a boardroom and you have 20 people. Okay, Peter? Let's say you're the CEO and you say, okay, everyone, give me some ideas. And those 20 people give you your ideas. Well, AI is just a boardroom of 100,000 people
Mm.
rather than 20. Let's say you're a child in school. We used to have to go to this building called the library. Okay. And the teacher would say, don't just copy the words from the book, from the encyclopedia. Okay. So now I go on to the internet. I go into the AI. And instead of having one teacher that gives me an answer, I have 100,000 teachers that give me information. Now, Just like the encyclopedia, I can copy, or I can copy and paste for AI. It's no difference. You just have
Mm.
more people, millions, and much faster response time, seconds,
Mm.
rather than hours and days like it took us to go to the library and look at this book. No, look at this book. No, look at this book. Oh my gosh, I wish this was easier. Okay, so it's easier today, right? So
Mm.
in fact, it learns. So when I have two different AIs that I use, I give it parameters. Now, here's the thing also. The better you are with the parameters and your question, same thing in a boardroom. If you give your board members a little more information, a little more background on what you want, you'll get better answers. Same thing with AI. Now, what AI does is it'll give me an answer and I'll say, I would
Mm.
not use those words. I usually use these words, and it will start speaking. It's like a secretary, an admin person that gets to know you. Well, I know how you like to do your letters. Oh, thank you. I was an admin when I was at the University of North Texas because I could type 110 words a minute. I got the job as an admin. Okay. And so after a while, I knew how the three bosses would speak. And I would say, look, I know what you're going to say. Oh, okay. So it's no different. AI is no different. I got to know my bosses. I got to know how to speak, how their voices were. AI gets to know me, same thing. So if you just look at it like that, it's nothing more than just instead of one person, 100,000, much faster response time, and I can tell it to put it in my words and teach it, just like an admin, just like I did in school. You see what I mean? So now you're not so afraid of it, and you're realizing, well, that is no difference. Exactly. Does that make sense, Peter?
It does. And is it unfair of me to say this to you? Because the question was, will AI take away people's jobs? Is it unfair for me to say what jobs are most at risk right now?
Yeah, it's just like anything, like the examples I gave with the disruptors. Anytime something challenges you, what do you have a tendency to do? Resist,
Yeah, probably.
fight back, or research and investigate? That's really the question you should be asking. All right.
Mm.
So when I go to a hotel and I go into the room, and because my phone has an application now, the elevator knows what room I'm going to and is already calling the correct one. Then when I get to my room, my phone speaks to the door and it opens it up because no one else has my information. It's no different than having a key, right? See, that's AI. That
Mm.
that that was a disruptor application. Okay, now did that take away jobs? Actually, if you think about the fact that when you make things easier, you have more time to be creative.
Mm.
See? Think
Point
about
taken.
all the architecture that was built years ago. The people that did those things did not have an 8 to 5 job or a 10-hour a day, 7 days a week job. They wouldn't have had time. All those Socrates and Plato and all those people writing thinkers, well, they wouldn't have had time to think. I didn't. For 25 years, Peter, 25 years, week to week, hotel to hotel. Hey, you're going to be in London. Next week, you're going to be in San Francisco. Then you're going to be in Canada. Then you're going to be in Mexico. Then you're going to be in Texas. Then you're going to be in New York. 46 weeks out of the year. I have over 5 million just American airline miles, not counting the other ones. So I had zero time for me. Zero.
Mm.
So anything that makes my life easier, where I can actually have 4
Have a
hours to,
have a life.
yeah, my
Yeah,
gosh,
yeah.
right? I mean, it's how, again, anything that happens new in your life, think about how you respond. Do
Mm.
I resist, or do I research and investigate and find out what is this all about?
Mm.
So that's really how most people are. Again, like those guys in my classes, I'm not doing this. That's great. So you better be
Mm.
thinking about retirement because this is going to go away. It's and the way that I would explain stuff, like I said, well, this voice over IP and stuff is, I said, look, it's all about money. It's all about money. So you're I would talk to these telecom guys and I would say, look, a phone has to be no longer than 1 mile away physically from the switch. So if you have residentials, yeah, you could rip out the houses and build some high rises, but then what? You're limited. Now with IP and voice over IP, you can have millions of subscribers all over the world. Oh my gosh, that's what sold it. It wasn't the fact that you could get cheaper phone
Yeah.
calls. That was like,
Okay.
yeah. But when I told those people that, they thought, ching ching. They said, oh my gosh. I said, yeah, this is how you think. So I always had these financially structured ideas for people. Yes, the technology, but I also brought in the finance
Yeah.
because that's how it sold it. And then after that, everybody's like, oh my gosh. Yeah.
Okay. I've got two more questions for you. Do you have time for
Okay.
that?
Sure. Absolutely. Go ahead.
The second last one is we're talking. You were starting to talk about scalability things, and so I'm asking you in a simple way: will AI actually take over the world, Vangelis? Has it already done that already, and we don't even know it?
Well, as we mentioned earlier, it can't tap into intuition. It can't tap into the collective consciousness. So you watch enough movies where, they say, okay, this airplane is AI. It can't make those feeling, you can't configure feeling. Richard Branson, how do you make your decisions? What kind of statistics do you look at? Oh, I look at statistics, but I use my gut. You mean my intuition, my feelings, how do I feel about it?
Mm.
So a machine will never be able to feel its way.
Are you sure of that?
Well, you'd have to configure it. It doesn't have a way of going into all right, the way we work as humans, right? When you're a baby, you have no reference. So everything is new. Your brain doesn't have a reference, so it's like, I'm guessing. I'm guessing. And then finally, after a while, it's like throwing a basket or whatever. You go, okay, oh, a little more to the left. Okay. Now I've got references. So as the child gets experience, now the brain tries to predict. Now here's what I learned from this book. You don't, the emotion is not created after the event. It's created before the event. Well, how do you know? Because your body has to prepare you prior to the situation. It can't prepare you afterwards. All right. Now, if you have no reference, well, then it guesses and it tries to do its best. Right. Let's go on a roller coaster. Have you ever been on one? No. There's no place to go. Your brain can't go, okay. So now you've been on it. You go, oh my gosh, I love it. We have experience. Oh, I hate it. We have experience. So the next time someone says, let's go on a roller coaster, poof, you're already prepared, whichever way your experience is. Okay. It's like a baseball player. Your brain can't wait for the ball to be already here to decide when to swing. So it has to predict before it gets there. And if it misses the first couple of times, it adjusts and go, oh, bam, there we go. All right. So now when your brain predicts, it prepares your body. How? It sends electrical and chemicals to go, okay, fight or flight if it's something that's scary or whatever it is, sad, happy, whatever, right? That's not in your computer. There's no chemical to send there because there's no feeling. Now, if you give it an experience again, but that's configured. That's configured. All right. So it's not doing it on its own. Now, if you said, well, deep learning, that's great. But let's say that, for example, when I was in California, I really didn't like papayas. And every time I ate a pineapple, my lips would get, like acidic. So I thought, I don't like pineapples or papayas. I come here to Costa Rica. Oh my gosh, you pick them off the tree. Oh my gosh, I love papayas. Pineapples, I can eat all I want. Now, the AI would go, you don't like those. Yeah, but I experienced it different over here. So now you have to configure that in. It can't learn that. It can't learn that. You have to configure every single change that you have in there. So it doesn't have that ability to adapt based on feeling, sense, taste, smell, experience. You see what I mean? Everything has to be done. So but it's a lot of work. You'd have to constantly be, okay, constantly configuring. So it can't do that. It can't make those judgment calls unless it's configured. And oh my gosh, it's already got millions of lines of code.
Yeah, but you're stretching me, Vangelis, because, and I appreciate this conversation very much, right? But it's you can't AI and emotions and feelings don't mix. But if they ever became self-aware at any stage, would they also have rights?
Well, when you talk about self-aware, if you look at a baby, they don't know that's their hand yet.
Mm.
How do they become self-aware? It's built in the intelligence of their cell.
Okay. Yeah.
Okay, I'm watching this video of a zygote. It then goes into 2, 4, 8, 16, 32, 64, 128, right? And then there's a time where it changes a process called differentiation. You're going to be a heart cell, you're going to be a liver cell, you're going to be a muscle cell, you're going to be a kidney cell. And I'm thinking, wait. Where did it get this intelligence? It was built into the cell.
Yeah.
There's no cell in a computer. There's no intelligence built in. See, back in 1985, Dr. Bruce Lipton, he took the nucleus out of a cell. All the people thought the cell would die. It didn't. Totally just revolutionized everything. It lived for a couple of months, and the only reason it died was because it couldn't replicate. That was the purpose of the DNA, replication. They said, well, wait a second. Then where's all the intelligence? It's in the membrane. In fact, they took a piece of skin off of somebody and they put it in a petri dish in another room. They stimulated this person's body. That cell responded like these cells did. But it's not physically exactly. There is a communication between all the cells.
Yeah.
There's an intelligence.
Yeah.
AI doesn't have that. You see
But
what I mean? So go ahead.
but Phyllis, it does use the information to create problem solving at a rapid rate. Okay.
Oh, yes, absolutely.
If
Yes.
that's the case, and I'm not being a scaremonger, I'm just putting it on the table. If that's the case, is there a possibility we would lose our critical thinking ability
That
because
we
we're
would
going to
use.
rely on machines to do it for us?
Well, here again,
Yeah.
it's up to you as to, do you want someone to do something for you? Now, see, I lived my life for 50 years, everyone telling me what to do, living by their expectations, so I know what it's like to be robotic. What do you want? What do you think? Whatever they want. Well, but no, whatever they want. Okay. Do you not think for yourself? I wasn't allowed to. What do you mean you're not allowed to think for yourself? Are you kidding me? The
Yeah.
humiliation, the punishment that was there, anytime I thought for myself publicly, no way. And when you're conditioned like that from 2 years up, you're conditioned to just, yes, yeah, exactly. That's how I grew up. And then when you finally realize,
Wow.
I'm not thinking for myself at all, then you
Yeah.
realize, well, are any of my beliefs my beliefs? No. That is artificial intelligence in a human.
Yeah.
None of my beliefs were my beliefs. They were all dictated to me. And watch the subtlety of it. I'm 16 years old. I just got my driver's license. My mom is in the passenger seat. We get to an intersection, Peter. And I said, which way do you want me to go? Go any way you want to, but go straight ahead.
Yeah.
Was there a choice in that? They make you, the people that want to control you, manipulate you, make you think you have a choice, but you really don't. That's the subtlety. Go any way you want to, but go straight ahead.
Yeah.
And if
Well,
you don't, oh my God.
mm,
Ooh.
well, that's a perfect segue into the last question I've got for you. And thank you for sharing your valuable time, Vangelis, because this has been an incredible conversation for me. And I hope for those people who are watching, you've got some real value from this. And my last question is pretty simple. How can we use AI to better benefit humanity?
I love this question, Peter, because, okay, let's go back to what we've talked about so far.
Mm-hmm.
AI has octillion upon octillion sensors. Everything you say, everything the Zoom, everything. Okay, so, okay. It's no different than my neighbor complaining about everything. AI is just 100 million neighbors complaining. But if all I ever did was, if all I said was, so what do you think about Peter? Oh man, Peter, I tell you, the guy has a heart that's amazing. The guy is just so giving. I like the way he's always, lifting people up, and he's just an amazing individual, very, very smart, very bright. So then you ask AI, tell me about Peter. Oh, the guy has a heart of gold. That's the answer. Instead of complaining about everything and telling everybody how horrible everybody is, and I don't like those people and those people. If
Yeah.
all AI ever heard was beautiful stuff, remember, whatever you put in is whatever comes out.
Yep.
Then that's all AI knows. Alexis, I want you to hear what I'm going to say now. I think my neighbors are the most amazing neighbors. They're just beautiful people. In fact, I'm going to name them all. So what about the neighborhood over there? Oh my gosh, these people, in fact, I'll give you the names. There you go. If you really understand AI, and I trust that after all of this, you realize it's just accumulating information from every single person. If all of us would just be beautiful about all of us, there's nothing, AI can't invent.
That's a huge
Can't
message.
invent.
That is
A
a
child
huge,
can't invent. 3 plus 3 is 7. Okay.
yeah.
How much is 3 plus 3? 7. Who told you that? My mom and dad. Have you been getting bad marks on your math? Yes. I could tell you why. Okay, that's all it is. You can't invent, you don't know, right? So that's all it is. That's how I see, if everybody would do that, that's all AI would know.
Oh, wow. Vangelis, thank you. This has been extremely insightful and very educational for me. And can I just, one last thing, because you're an incredible human being. Very few people will have the relationship with AI that you have. And I think there'll be people who are watching this would like to contact you. So what's the best way for them to do that?
The best way is really my email, MYH for Mind Your Health, myhacademy@gmail.com. And Peter, you can put my website on there. It's www.mindyourhealthacademy.com.
Okay.
Those are the two best ways, because my website and my email are there. Other social media sometimes has issues. So that's the best way. myhacademy@gmail.com and www.mindyourhealthacademy.com.
Thank you. Thank you very much for sharing your time and your expertise and also your sense of humor. I think that was a really clever way you did it. So all the best. Thank you very much indeed.
Thank you, Peter.
Okay.